So I'm Mark and this is Warren, and we have been working on a project and having some fun with it over a number of years, mostly in the South Canyon lands. J.J. Autry, who taught here briefly, gave us a call a number of years ago. I don't remember how many now. You, Warren? 5 years ago?
Sue, you were still here.
Longer than that, to be at least 7.
It was about 7 or 8 years ago, yeah.
So JJ, when he left here, he went to work for the Nature Conservancy, and they had acquired a 55,000 acre property down south in some of the Red Rocks Canyon areas. And he asked if Warren and I and others would be interested in coming down and doing some research and some field work. It started out with wildlife camera traps, and then it kind of morphed from there into paleontology, geology survey, more wildlife work, and some other things. So this little slideshow that we put together is just to kind of brief folks in the community and here at the college on some of what we learned. So Warren, if you want to.
I got our first slide.
You bet.
All right, so this is the first slide. And, in terms of paleontology, this wasn't, I would say, the richest area. This was more for the archaeology. And I'll just point out a couple of things here. And I have to admit, this is more Mark's realm. But what we're doing is we're looking at some about 220 million year old rock formations here. And you can see at one time they were sand dunes. You can still see what looks like windblown sand here. And you can see the Chappaqua Creek here runs in the bottom, and it only has water in little parts, and a lot of times the water dives underground and then it resurfaces, and you can see a little bit right here. But this was an ideal spot for some of the indigenous people in this area to set up a shelter, which would have been located right in here. Am I doing all right so far?
Yes.
All right. And so you can't really see it, but there were some corrals in there, and there was a dig site. Most of the fossils we were finding, however, were up here on top. And then another canyon or so over called Alejandro Canyon, which will show some pictures of dinosaur tracks that we see, again, about 220 million years old. So go ahead and add anything you want.
Sure. So Kimberly, who introduced us, is a PhD in archaeology. And when I became acquainted with her when she was over at TSJC, we decided that we would go down and reopen a site and do some archaeological work that had not been done since the early 60s, I think. Do you remember when Campbell was down there, Kimberly?
I think 64, you published in 67.
Yeah, so mid-60s. So we went back down and took a class out. A few students from Trinidad, a few students from here at Otero, and did that work 4 years ago now, coming up. But that was more of an archaeological project. You'll see a few slides about that in a bit. But Warren is exactly right. Those dunes are what we call the Jump Formation. And on this, no, that's fine. I can point. So this pinkish stuff is Jump sandstone, and it is kind of solidly in the middle of the Triassic. But it's pretty much barren of fossils. We've never found anything in the gem, not trackways, nothing. It's just a bunch of massive structures of windblown pinkish sand that were deposited in the upper Triassic. But above that, you can see, and this, by the way, we have to give credit to Bruce Schumacher, who was our longtime paleontologist here. Fabulous human being, but beyond that, a wonderful instructor and also resource for us as we did some of this work or tried to get started. You can see at the very top of the jump it says Chile equivalent, and another colleague of ours prefers that we call it the DACA, kind of the eastern portion of that, but it basically is upper Triassic in terms of years, somewhere between 210 and 220 million years old. And so that was the focus of our research for most of the time we were down there.
Something you might call something that you guys are probably more familiar with when we talk about the Chinle or the Dockham. We're talking about areas like in Arizona, the petrified forest. Is what most people would think of as the famous region where a lot of these discoveries occurred. We have a little bit of that right down here in our backyard, or at least that same sort of time frame. So that might give you a better sense if you've ever driven through petrified forest. We're looking at a similar sort of set of index fossils that would be out in that area.
So this is one of the thicker deposits of this Chinle equivalent or Dockham formation. If you look really carefully, kind of upper center part of the picture, that's Christian Nielsen and also Bruce Schumacher. Warren and I think we're working on some fossils and burrow sites and doing some documentation below. But these two guys were actually scrambling up and down, measuring the actual thicknesses of each of the little members or parts of this formation.
We'll show another picture later down in this region. As you look down from it, there's a bunch of burrows, what we think are burrows of ancient organisms. We don't know what they are, but we have a few hypotheses on those too.
So if we kind of take the information that Bruce and Christian were able to gather in the field and then document that graphically, that's what that lower picture is. And you can see that above it is something called the Ralston Creek Formation. This is now more thoroughly described part of the Upper Triassic. And then here's that Geln sandstone massive deposit below it. Below that, there's also undifferentiated Triassic material. Of course, unless something really strange happens, the deeper it is, the older it is. So there's another unconformity or a break in the timeline. Below that gel, then you've got that undifferentiated Triassic material that we still need to learn more about in southern Colorado. But then even below that, there's some Permian material which dates back to about 250 million years old. And that's really a formation that needs to be discovered and studied and thoroughly picked over because it hasn't been described very adequately in Colorado.
So I'll jump in here and talk a little bit about this. So I had to bring my prop. This is a little bit of the same material that this jaw was found in. And the day we found this, we had a Science and Society class out there, and we were wandering around, and Mr. Korbitz was talking about the dinosaur tracks that we had described. And I was wandering around because I've heard Mark tell us stories on that quite a few times, so I decided to wander off. And one of our students followed me, and he said, "What are you doing?" I said, "Oh, I'm looking for bone fragments." And he goes, "What do they look like?" And I happened to see a bone fragment right at the edge of the creek. Is that the next slide?
Yeah.
Right there where the notebook is. And I bent down and I picked it up and I said, "Here's what they look like." And I handed it to him. He's studying it and he goes, "Mr. McClure, this has teeth." And I said, "It's not a tooth," because I don't listen. I'm just like my students. I was like, "It's not a tooth." And he goes, "No, it has teeth." And I was like, "Give me that." And so I look at it real carefully. I'm going to go back a slide here. And what was in it was this. Now, it wasn't this exposed. But what he was seeing are these little serrations right here. And that's what gives this organism its name. It's a Sphenodontium, which means wedge tooth. And so Mark and I got pretty excited. I called Mark over, and Mark comes up with his hand lens, and he's looking at this, and he goes, "It has an incisor." This big giant tooth sticking up front. And we're like, "We found a mammal."
We thought maybe the first mammal on planet Earth.
Yeah, we thought we pushed the mammalian evolution back another 5 million years or so. We're thinking, we're going to be famous. I don't know if we were really thinking that, but we were excited nonetheless. And so I think that was our last day out there, right, Mark? Because we came
Yes.
back that night.
You always find the best stuff in the field when you're running out of time.
I'll just, it's not actually in here, but if you want to see what the material looks like that we found in a lot of these fossils, then you can pass that around. But anyway, so we come back that night and
Went in the lab.
we went into the lab and Mark, because we were looking at this under the microscope, we're like, this is a mammal. Because that incisor, usually you don't see this sort of tooth differentiation in this sort of creature. So we're thinking this really was a mammal. And so Mark looks up the world's expert, Dr. Watt of the University of Chicago.
Yep.
And Mark emails it. I think it was less than 8 hours later, we get an email back saying, this is exciting. And he goes, I can't meet with you guys now because I'm in China. He was doing a dig in China. But he thought it was important enough, so this gets us really excited. We're like, oh, the world's expert in mammals. Then he's like, we'll meet you in October at the Paleontology conference down there. And so we get our stuff together and we head down there, we put a poster together, and we get down there and he tells us, sorry guys, it's not a mammal. But he did say it's probably a new species, and I'm getting ahead of things, so let's go ahead and say this is, though, about 215 million years old, somewhere in that time frame, and it is a new species. So let's see what we can learn about that. That's where we found it. This, I gotta give Mark a lot of credit. He's a pretty good artist. He doesn't give himself enough credit, but this was his artist's version, or what he envisioned this creature to look like. So the only living organism today that matches this at all, it's in the same genus, is a tuatara. If you guys ever heard of tuatara, you're shaking your head. Where are they from? New Zealand, yeah. So, yeah, down in the southern hemisphere. And they're not really a great representation of the majority of these organisms. But it looked something along these lines, and you can see Mark's got the little tooth pointing out there. So I give Mark a lot of credit. I don't think I would have the patience to try and draw this. All right, so Mark, do you want to talk a little bit about this?
Sure. So one of the things that we emphasize in earth sciences all the time is that biological evolution is a unifying idea or a theme, certainly for the biological sciences. It kind of helps things to click together and fall in place and make sense scientifically. And in earth sciences, plate tectonic theory does the same thing. Dr. Alan Nolan he can tell you, plate tectonics comes into everything in earth sciences. So I think it's really instructive sometimes to say, what did the earth really look like at about this time? And this is a pretty decent representation. Colorado would be about where Warren is, put the laser pointer. Notice that we're just north of the equator, 215, 220 million years ago. And Pangaea, the supercontinent, existed. So things were much, much different here than they were then. Sometimes when we visit with landowners and other folks, it's kind of hard to convince them that, no, the canyons weren't here then. It was very, very different. No, the river wasn't there. No, the dinosaurs were not following the trails that the deer now are trekking back and forth on.
Actual conversation we had.
Yeah, things are completely different now than they were then. Global warming has happened in the past. It was much warmer at certain periods of time in the Jurassic and Triassic, but you had one supercontinent, and that's part of the reason. So I put this in because
and I got ahead, so
it's kind of a running gag or a joke between Warren and me and whoever comes with us, because we always say we're going out to find Adelobacillus. Adelobacillus is according to Luo, it's the first mammal, has all the characteristics of a mammal. Well, how do we know that? Because of this. If you and I were just walking along and saw this thing on the ground, it would be about this long, about as long as your thumbnail, and it's crushed But there's one sample of this organism, Adela bacillus, that's been found. And it was found down in West Texas when they were screening through some upper Triassic material. And then the diagram at the bottom shows the different openings in the skull and all that. But nobody's ever found, since 87, I think is when this was found.
Sounds about right.
Nobody's found a piece of Adela bacillus since then. So Ward and I laugh about, well, today's the day we found an entire Adela bacillus skeleton. And this is what this creature looked like. If my wife Sue, who's sitting over here by Dr. Gray, she would take one of these home, I'm sure. We would have 6 of them, and she would successfully breed Adela bacillus. That's how she does with chickens anyway.
Sorry, I jumped ahead, I wasn't sure.
No, that's fine. Go ahead.
You want to take this one?
Please.
All right, so Sue might have been here for this part of it, so not Sue the dinosaur, if you know that Sue is. That's a T-Rex. But Sue, who's sitting over here, I was out with JJ on one of our first scouting trips to figure out where we might put wildlife cameras. And we drive across a little ford across Purgatory River there. And he parks, and I look out the window, and I said, JJ, you have dinosaur tracks here. And he goes, yeah, I know. He's like, has anybody ever described them before? I don't think so. I was like, can I? He said, sure. And so this is where I got to pick on Bruce Schumacher a little bit. It's the only time I ever get to pick on Bruce at all. I take pictures, I draw this up, and I send it to him, and he ignores me.
Well, and Warren brought him back, and he said, Mark, look at these. And I did, and I said, no, those are tracks. No doubt.
And Bruce, I took everything over to him in person. He looks at me and he goes, Warren, you're right. I need to apologize. And he's like, I have people bringing me dinosaur eggs once a week, and I have to tell them they're not real. He's like, I should have known that you and Mark were more thoughtful about this, but I'm very busy. And so anyway, I tease him about that now, that he ignored me the first time we pointed these out. So what's really cool about this is these are, whoops, put the wrong button there. These 2 tracks here are the last 2 tracks. Actually, there's a third one we uncovered right here now. My students last time we were out there, we uncovered yet another one. But these 2 tracks are the last in the series. I think we're up to 17 tracks now in a row that all walk along. These were completely covered by overburden, and we were able to remove it and identify these 2 new tracks. Initially, I think only 12 were exposed. We got more of them exposed, and what's really cool about these tracks is you can see there's some digits here in these tracks. And so again, we're always reaching out to people to ask them, what do you think this is? Has this been identified before? And it was identified, I believe Bruce came back and said it's probably Eosauropus. And Eosauropus, we don't know what it would look like in terms of fossils that most people think of in terms of bones, because it's only identified by ichnofossils here, which are the footprints. So it has its own name because they're identified by footprints. And so these are 2 of them, and we were able to get this published, and this was our first presentation that we did down in New Mexico at the Paleontology meeting. So I'll pass this around if you guys want to look at it. You don't have to read it or anything like that. I wouldn't recommend it, actually.
No, it'll put you to sleep.
But you can see the dinosaur tracks, but they had some weird gating patterns. And so we don't know if this guy was slowing down, speeding up, he was injured, stumbling. So we addressed that in there because there's some weird gates. And the other ones have a much wider spread between each footprint. It looks like it was slowing down at this point. And there's a hypothesis that these guys were facultative quadrupeds, which means part of the time on 2 feet, part of the time on 4 feet. And so we think it probably looked something like this. Now this, I can't give Mark credit for this one.
Yeah, this is actually Mosaurus, which was found, much more complete remains of which was found down in Argentina. But if you remember, Argentina, South America, North America were all basically glued together anyway at this time.
So South America.
So yeah, it's not real far. It's not a stretch to imagine that prosauropod was maybe the same organism or closely related to the same organism that made those tracks. What's the importance or significance of it? Dinosaurs and the first mammals basically showed up on planet Earth and evolved at about the same time. The mammals, the first mammals, were from a group called Sphenodonts, and then the dinosaurs obviously had a tremendous period of adaptive radiation and incredible success all through the Mesozoic, and the mammals stayed kind of little, small, hiding out, coming out at night, burrowing into the ground or hiding under logs, and just sort of waiting, apparently, for their chance. And then, of course, when the asteroid hit the planet down in Chicxulub, the Yucatan, about 66 million years ago, all of the large dinosaurs, except some of the theropods that became birds and were birds, those were the only clade that survived, and the rest of them were gone. We find no bones of dinosaurs of any large version after the dinosaur or the asteroid impact knocked off the dinosaurs. And then the mammals, of course, took off and filled all kinds of ecological space.
I'll let you keep going on some of the...
Yeah, this is a kind of a cool artist rendition of an Edosaur. An Edosaur is a very common fossil that we find in the Upper Triassic. And so we find these little armored plates and things that obviously were evolved and developed for protection. And I think the next slide shows you what we typically find. So I think that's my thumb, but that's just a piece of an Edosaur plate. Again, it dates back 215 to 220 million years old. And we're fortunate to find a piece or a chunk of material that's that large now and has survived. After that many years and exposure to elements and water running and freeze-thaw cycles, we don't find integrated pieces of material typically. It's usually just bits and pieces. So Warren, why don't you talk about the burrows?
All right, so if you recall back to the previous picture where we had our two colleagues up on the hillside, this is the image I was talking about looking down. And we have yet to really determine exactly what these are, but almost everyone we talk to now believes that they probably are burrows. And so you can almost imagine this is a modern prairie dog colony if you want to think of it that way. But the thing about this is there are some, do we have another picture? Yeah, so we have some images from the side as well where the rocks have broken away. And we can see these burrows going down at different angles. We even have another one, and I don't think this is it, but we do have some that are running transverse as well, that are moving across the rock this way. And in this particular one, we found a little bitty piece of bone that was almost the exact same shape as our previous jaw that we put up there. And we got really excited about that, but unfortunately it was so thin and so weathered, there was nothing really that we could glean from it other than it was a small bone fragment. So unfortunately we were thinking, oh, this might be some evidence that it was actually these Sphenodontians that were doing these burrows. But again, little hand waving on that, which you have to do a lot of when you're coming up with hypotheses on these things.
So another point I wanted to make real quick, if I may, that is that technology is such an incredible gift to us. And sometimes we take it for granted. I tease and make jokes about how addicted, especially some folks are to, look at their cell phones constantly or whatever. But we took these digital photos in the field and brought them back, and then the resolution on it is so good that we did not even see that little bit, that tiny bit of bone right here, until we got back home. And then Warren and I were going through the digital photos and zooming in, and I said, hey, we got to go back to that spot. Well, fortunately, we also take GPS units when we're out in the field, and so we write down coordinates whenever we're in a spot. Here, I think in the next slide or a couple of slides, you'll also see this, which is, we think it may be a coprolite. We were at a place.
One region right there. You can see there's a fin-like imprint, and then you can see other little bone fragments that look very fish-like.
So we found this right next to a place called Lost Canyon, and it really is in the middle of nowhere. You take a four-wheel drive small vehicle to get into that area, and I happened to be walking along and I saw some little flecks of white. This whole thing, which we have in I think it's in the organic lab right now, but this whole thing is about that big. And I saw these little bright white flecks that the sun was shining on, and I knelt down and looked, and I wrote down our GPS coordinates, took this photograph and a number of others. We were able to take a chunk out of this, but Christian was with us, and he was sick. He was running like 103-degree temp.
And it was a hot day.
And it was 115 in the canyon probably, and we thought we might
Get out of there.
have to call Flight for Life or something if we didn't leave. So we did, and when we got back to the lab, I noticed that we'd left part of it behind. Then other things came up. We didn't get back out there for a year and a half, but because we had our GPS coordinates, I was able to walk to exactly that same spot and find a little tiny piece that was still embedded in the rock, and then we were able to get the rest of it out.
So, not to think we know everything, there is an alternative hypothesis that we heard at one of these meetings on what this might be. They say occasionally fish will die and they'll get rolled up in a mud ball, and that's an alternative hypothesis. The coprolite is one of them, where something ate it and then the fecal matter fossilized, or it could have been a mud ball where it rolled up. And I just saw Steve nodding over there. Apparently you've seen something like that?
Yeah.
Yeah.
Sometimes after from floods and all, as they're kicked around from a flash flood, they can get caught up in the mess. And I've actually seen fish on that.
So yeah, that would be an alternative hypothesis to what we were thinking. Anyway, so now we're going to do it. Go ahead, Mark.
No, this again was on, I think, the west side of Lost Canyon. One day we happened to be driving along, and I hopped out and I looked at some conglomerate that was sitting out there. And this is sort of a half section, obviously, of a tooth, and it's probably about 3 centimeters long, and the rest of the tooth is missing, but it belonged to a creature that's called a phytosaur. And this is next picture. These were the apex predators at the time of the Upper Triassic. So if you were an etosaur, the reason you needed to have lots of armor plate is because these guys were wandering around. And these are just two species that are drawn to scale, kind of like long-legged, probably fast, very, very aggressive and predatory crocodilian reptiles. So I had to throw this slide in because Kimberly and I talk frequently about scientific topics, and Sue's, my wife, knows that one of my pet peeves is when people who are experts in their field kind of get confused about really important details. I can't tell you how many times I've heard people who have like PhDs from Oxford or Harvard or wherever sometimes get this mixed up. Archaeologists study human material trash, essentially. Stuff that human beings have altered or left behind, or footprints, or human bones, or cultural material. Paleontologists sometimes kind of overlap a little bit, but paleontologists study any fossilized remains or material of living remains, or tracks, or footprints, or drag marks, or anything like that. So I always try and clarify at least one thing in the course of a day, and this is one of my pet peeves. When I'm watching like a program on Nova or something, and they get this messed up. Paleontologists do not typically study human culture. Paleontologists focus on the bones and the animals, and sometimes people or the ancestors of humans, but there's a big difference.
How do you do? All right.
So this is just one example. This is a piece of geology, obviously, but it's a really weird rock. It's called I forgot, Bridger Basin Zebra Chert, kind of a long fancy name. But essentially it's a very unique kind of rock with these stripes through it. And some of you may have heard about Clovis cache of material that was discovered up in some guy's backyard in Boulder, up in the foothills. I think it was about 15 years or so ago. He hired some people to come in and do some landscaping, and they were digging around and they clinked into some rocks and they dug it up and they looked, and some of the pieces were actually this Bridger Basin zebra chert. There's only one place that we know of in North America where it naturally occurs, and that's over in extreme northwestern. We heard that, Warren. We heard that.
Sorry.
No, that's all right. It comes from this very localized portion of Utah and Wyoming. And so we know when we find an artifact like this laying on the ground in a place like J.E. Canyon Ranch, that there was some trade or there was some material. So yes, it's a geological sample. Yes, it's of some interest geologically, but it's kind of helpful and useful if you have a little bit of knowledge about more than one topic, so that if you're in the field and you find something that's weird, you're able to go to somebody who's an archaeologist and say, hey, we found this piece of zebra chert. Or do you have the clicker?
I got you.
All right. This is just one more quick example of the base of what probably started out Kimberly as a paleo point, and then it broke, and then they refashioned it and tried to kind of reuse it probably as a point later on. But it was over by Lockwood Canyon. And Warren, you got to talk about these because your eagle eye was the one that found it.
I guess I should turn the sound back on now. Had to send my son off to karate. I apologize. Anyway, we were looking for fossilized bones. The other Sue was with us on this day. And we're wandering around, and when you're looking for bones, you don't find them. Instead, you find arrowheads. And it was funny because this day we were really trying to do a thorough survey for bone fragments that were on the surface. And I happened to look down and I found this one, and it's the best one I've ever probably personally found because it was only missing just the little tip of it there. So I was really excited about that. And probably 30 minutes later, I found this one. And I don't know that I've ever found anything other than these in terms of was it good?
Yeah, that's really fuzzy.
So in terms of archaeology here, this is really the only stuff that I've ever felt that I could say, yeah, I actually got lucky and found. But anyway,
two of them in one day?
Yeah, two of them in one day, probably about a half hour apart when I'm looking for something entirely different. I don't think I found a single bone that day, though. So anyway, on we go.
We were also driving down a road next to Alejandro Canyon, and I saw just a glint in the middle of the road. So we backed up, and I jumped out and looked, and it was this very fine quartzite lithic tool that was in the middle of the road. I went ahead and wrote down the data on it and picked it up because it was going to just get run over and crunched up into pieces. But you find this kind of stuff if you're paying attention, is what I'm saying. And it's just a matter of kind of knowing where you are. And this, obviously, the rock that this is made out of is millions of years old, but the artifact itself, as fashioned by a human, how old would you say that probably is, Kimberly?
That's pretty non-diagnostic, it's just a tool, but the other two are middle archaic, so like 6,000 to 8,000 years old.
So the other two, Kimberly said that the other 2 points that Warren found, middle archaic, so maybe around 6,000 years or so old, which is substantial. And then this is a photograph, the one aerial photograph at the beginning of the presentation. This is, bless you, this is actually down in the Medina Rock Shelter, and it's one of our students who was up and you can see the old corral there that Warren mentioned before too. And one of the things that we did, I'll get out of the way so you guys can see, one of the things that we did was pay attention to environmental conditions. There's another rock shelter we'll show you a picture of, I think, here in a little bit. But this pretty much faced to the east in this portion of the rock shelter. And Doc Gray was down there with us too. And it was really, really hot. Once the sun got up high enough that it sort of overwhelmed the overhang, and it was beaming back into this rock shelter, we recorded temps as high as 119 degrees back against the rock. But at the same time, if you follow this kind of back through where it's still facing north, at the same time, one of the ranges that I recorded was a temperature of 106 degrees Fahrenheit in full sun, but in the shaded southern north-facing portion of the shelter, it was still 57 degrees Fahrenheit. So without a doubt, there's this natural sort of air conditioning effect that these people would settle and spend time in the areas where they'd be most comfortable. And this is a picture of Cedric and me. We were trying to get a part of a bison bone out of the bank, this alluvial embankment below, and then this is just a picture of the bone before we took it out of the sediment. And this is it once we got it out, and then we were able to spend a little bit of the college's money to, this is another site.
I want to stay on that
Yeah,
side.
no, you're fine. This is about 3.5 meters below surface. Goat Ranch Canyon, Goat Bend Canyon. Anyway, yeah,
Should read your own slide.
yeah, I should have known or remember things.
I should read the slides.
We took samples from both of these, and I'll be real honest about it. I was really thrilled to go down to Medina and then this other, we call it Bison Bone Rock Shelter, because I thought it might give us an opportunity to find some really nicely stratified areas and sites where we would have these beautifully discrete cultural horizons. And what we discovered from doing radiocarbon dating on Kimberly a hearth and maybe a couple of pieces of charcoal, but then also on these bones, is that the oldest C14 dates that we got from this stuff was about, yeah, it's here.
I'm trying to get to that data for you. Didn't you have the graph in here?
Just back up. No, I didn't.
Oh, I got the graph.
Right there. Oop,
Sorry.
there you are. So between 2,200 and 2,400 years before present. So much, or a big, huge portion of that alluvial deposit was thrown into these rock shelters in a massive, massive flood event about 2,200 to 2,400 years ago, which churned up material. We found more artifacts that dated back 7,000 to 8,000 years, but it was all like it had been put in a blender, unfortunately. So that was a bit disappointing.
Don't forget that it also was the gopher pulse.
Oh, Kimberly points out that in Unit 1, there were a lot of gopher holes and animal activity and, darn animals. Snow helps. Warren, you want to talk about this a little bit?
So one of the things that I'm going to admit, this isn't, dendrochronology isn't my thing so much, but it plays a really important role, especially when you get some really old trees. And some of the, is this a juniper?
Yeah.
Yeah, so a lot of these juniper trees out there can be 1,000 years old or more. And so if you can get a good section, you can actually count the rings. And there are a lot of people who go in and study the rings of the trees to figure out what happened. Was there a fire? Was there a really wet year? All of those types of things. And so you can often use dendrochronology as a way to give you an idea. If we had a tree that was 2,500 years old, we might be able to find that there was a really wet year and that's what caused that flooding event that maybe killed all of the bison or whatever it was, whatever other things were found in that event. So you can use these tools, and we did a little bit of this. We took some tree cores where you basically drill into them, pull them back out, and you can count the rings and leave the tree alive and intact. I don't believe this is one of ours, is it?
This is actually a section that was buried in Unit 1 at the archaeological site in the rock shelter. And so it was part of a post that was buried down in the ground, right next to a hearth, if I remember correctly. And so when we pulled that out, excavated it, drew it, photographed it, and then we cut it and polished it, sanded it. And I don't think I put any oil or anything on this. This is just using finer abrasive, and you've got it. We still have it back in the lab too. But it shows all this incredible detailed structure. The problem here is we don't know how this piece of wood would fit into a long chronology to be able to say, hey, exactly when did that piece of juniper wood, when and how was it used or cut by native people? Could have been a few hundred years ago, or could have been thousands of years ago. And this is a picture of Kimberly and one of our students at the first unit. You can see some of the discoloration and stuff. The point that I was making with some of these photos is some paleontological skill is useful sometimes when you run across little bits and parts of animals and things like that. But you also have to be willing and ready to say, hey, we need to send some photos to the real experts. And most of those folks are really helpful. Drone technology is kind of fun to use too. This was a drone photograph taken from above Unit 1, where Dr. Gray and I slaved away for, seemed like years.
Unit 2 would have been back up on this one. Or is it that way? Is it right? Okay. This is not my area. All right.
And this is that other rock shelter. You can kind of get an idea. We kept trying to think of reasons or why we would want to be there in the summertime. It has this huge rock berm out in front of it, and this is about a mile downstream on the Chippewa. And if you look carefully on the left, you can see some of the students, and I think Kimberly is resting on a rock or something over there. But there's this pour off, and it is so well shaded. This is in the middle of the day, and probably high temps of maybe 60s or 70 degrees when it's 110 or 115 Fahrenheit in the sun.
Did you want to say?
No, might back up. I just would mention really quickly that our efforts now are we're working hard with the administration's help and Kimberly's leadership to achieve repository status here at the college on both the archaeological and the paleontological side of things. Continue to do some geological and fossil location explorations, but extend sort of temporally away from Triassic into the Jurassic and Cretaceous as well. And then also opportunity recently to consolidate some of the material that was originally done, work and material that was acquired by Galen Baker many years ago in the 1960s and 70s when Galen was here at the college. And then organize some of that material and hopefully publish some of the results of that work. Thank you to all these people and others.
So just take questions now. I was going to pass around. So Mark and I have been lucky enough to pair with some really great people. I want to point out the first author on this paper. He was kind enough to include Mark and I.
Who is that?
Ben. Ben just finished his defense of his PhD in paleontology, so we get to call him doctor now. He hasn't told me he didn't pass, so I'm guessing and the guy is brilliant. He's the one who really did a major amount of work on the Sphenodontian. And we have the jaws here?
Yeah, we passed them out.
Oh, there, okay. So those jaws right there, they're actually in reality only this big. He did a 3D scan of it using CT scan technology. It actually works on fossils now. And so you'll see some of those images in here. So I'll pass this around too if you want to get a little more detail on that. We were able to slice them, 3D print them, and now we have versions that people can actually handle.
That's a little bit of a fun story too. So that little tiny jaw that Warren found and that we were able to analyze, it went from next to the Purgatory River to here at Otero, and was in our lab for a while. And then Bruce took it, he did some of the prep work around it, then he got nervous. He said, I can't do any more, brought it back to us. Then we shipped it to Ben at Virginia Tech, then it went to Duke University for scanning, then it went back to Virginia Tech, then it was shipped back to us here, and now it's up at the Denver Museum as a holotype. So, oh, I wanted to also say something about Dr. Luo. I stumbled into something that I think is kind of important for those of you who have any interest in academics. One of the reasons we reached out to Dr. Luo at University of Chicago is that I think that there are clues, maybe it dates back to a little bit of experience I had with the federal government when I worked briefly for the FBI. But when I look at a researcher and every single publication they list, their name is first, it might be a clue that might not be the kind of person you want to necessarily collaborate with.
Don't go too far.
No, I won't. But Dr. Luo, it was interesting because his first papers, of course, he was a young researcher and his name was first, but every single paper after he became a full professor, his name was always last. Last name, last name, last name. He was putting all of his grad students and all of his postdocs and stuff ahead of himself. So I said, hey, Warren, this is the guy we want to contact because maybe he's not a jerk. And he's not. I know that's preserved forever, but that's the truth, and I'm sticking to my story.
Don't read into anything of my name being first on one of those. So questions, please. Yes? BP and time.
Oh, yeah, sure. So the question was, what does BP mean when you see it? So many, many years ago, when I was a student here, a long time ago, we used to still use AD and BC, but since then it's become a convention to use BP quite often, which is before the present. So especially when we start using radiocarbon dates to go back 20, 30, 50,000 years, quite often you'll find calibrated dates BP, which means before the present, which generally goes, what, standardized 1950, I think, or something like
around
that.
the time of the atomic bomb.
Yeah. Right.
Including the process that you guys found, find a form vegetation.
Well, I would say it depends on the type of bone you find. If it's in Kimberly's realm, and it's relatively new, not fossilized, not mineralized at all, that's something you probably need to get in touch with the indigenous people, the NAGPRA, and I don't know all of the appropriate channels for that. That's more of a Kimberly question. But if it's fossilized and it's obviously dinosaurs, Sphenodontian, something like that, in terms of channels, you can pick those up, but you always want to make sure you're marking where they were, the orientation they were. So you don't want to just go in willy-nilly and grabbing things. You want to document. You want to take pictures. What orientation were they in? You might have seen Mark had like a zebra-striped board in there. That tells you what direction they were oriented and all of those types of things. So your goal is to really try and keep it, even when you finally remove it, you want to be able to kind of recreate the in situ situation, which means what it was actually like when it was in the rock. Is that fair enough?
Absolutely. And I would say too that if you suspect what you found was human bone or human remains, you don't know if that's a law enforcement or forensic situation, or whether it's, a very old, ancient Native American grave or what. So that's what you call in people like Kimberly or even forensic anthropologists who come in and help make a determination as to what's going on. But with the stuff that because you know that this is consistent with an etosaur or with a metoposaur or some other creature that you're used to seeing. If you don't, I would quote a little bit loosely from Bruce in saying that those fossils that are found on the surface, especially, if you don't record them and notate the context and everything, they're going to just basically disintegrate and turn to dirt. So you need to capture as much information as you can when you find them in the field. And then some things like, pandemics can happen and might interrupt your work for several years too.
Well, we find some fossils just out in town, like in shale rock, white shale, seashells, and then there's another ground layer where we find different fossils. I was just wondering if you could show us on that topography and
absolutely
maybe where that shale, that white shale around there fits.
Shoot, you bet.
Is there a fast way to do that?
We'll go to. So the question was in the southeastern Colorado stratigraphic column that Bruce prepared.
It'll be a second.
Yeah, we'll look at that here in a second.
Space.
And there are a number of different really productive layers of sedimentary rock. First of all, this is obvious to say, but you don't find fossils in igneous rock. You don't typically find fossils at all in metamorphic rock because they were way too high and they were subjected to too great of extremes of temperature and pressure. But if you look at kind of clear up to the top, see where it says Carlisle Shale, and then Greenhorn Limestone, and then Granero Shale. Those are all, above Graneros, those are all super productive. And depending on the particular area, you can determine, it's a little bit blurry.
This over here, is that what
Well, yeah, all of it is, but one of the coolest things about this chart is that, by the way, if any of you want a copy of this digitally that's clear, if you would just put your email down, maybe on a sign-in sheet or something, and I would be happy to email the original chart to you, which you can see with clarity. But Bruce has gone through and he's used his roughly 25 years of experience here in southern Colorado to determine, okay, which of these are really fossiliferous and productive and good areas to look. He's even listed out there what kinds of places do you look to find those particular kinds of rock. So if you're careful, if you're paying attention to detail, you can determine exactly where you are. The big, massive sandstone, most of that we find, like chunks of it here on campus, are actually Dakota sandstone. Some of it's Purgatory Formation. And then, of course, this is that Permian that I was talking about being some of the older material, 250 to 260 million year old
What James was talking about really
That's
is
up here.
this up here at the top.
Really young stone.
Well,
Relatively speaking.
yeah, relatively, but see, Cretaceous material, during the Cretaceous, much of southern Colorado, eastern Colorado, was covered with the shallow sea. And so that's why we find all those limestone deposits and bivalves and sometimes plesiosaurs and mosasaurs and things like that. So, but we're still talking material that may date back to 70 or 80 or even 90 million years ago.
How do you guys settle on the name?
That's the name of these or the organisms? So, well, the Sphenodonts, I'll talk about that one because that's the only species, genus and species I've ever had the opportunity to name. And I think that's true for Mark as well.
Yeah.
And we kind of debated, what should we call it? And then we kind of decided to go more with convention. A lot of times you name them on where they were found. So this particular organism is called Trulidens purgatorii. And purgatorii makes sense if you're from around this area. Purgatorii means it was found on the Purgatory River or near it. Okay, so that's how we came up with purgatorii, and you Latinize it, and that's where you get the the I's and the E's and things like that you put on the end of it. Now, Trulidens, we went with the naming convention. Trula means spade or shovel, and dens, your dentition, is your teeth. So shovel tooth is what the genus name of the organism that we got to name. So that's how we did it. Now, other people, one of our friends named Brian Small, he has I don't remember the exact organism, but it's named Brian Smalley Eye, right?
Yeah.
Brian Smalley Eye. So they named it after him because he was the only one and he's embarrassed by it, so I'm embarrassing him.
So we tease him constantly about how famous he is for having a dinosaur named for him.
But he's the one who prepped that. I think he even found it. He did all the major work on it. So I think his boss decided to name it after him.
I think it's a small sauropod, isn't it?
Small, no pun intended.
Yeah, a relatively.
Brian Small.
Hope that answers, James.
Yeah, and the Purgatory River, I guess that's down into that. How far is that river cut down?
Sure. So, yeah. So there was an uplift of material out south, and part of that probably was volcanic. And then on the south edge of that uplift, it erupted, and that's what formed those kind of dark brown black cap mesas, Mesa de Maya, Black Mesa down into Oklahoma, even Two Buttes down by Springfield, Lamar area. And those are volcanic, so those are more recent. But that uplift, as the earth or the crust of the earth was shoved up, the river cut down through it, and basically cut all the way down through all of those subsequent layers that are on that clear down into the Permian. So the very, very most remote, deepest parts of the Purgatory Canyon, you can find some Permian material. Yes, sir.
Was that a uplift? So where I live in Colorado, we have, the Continental Divide is right close there, where the two plates came together. So is this uplift part of that, where the two plates came together, and does that have to do with plate tectonics?
So Clinton's question was about uplift of the Rocky Mountain Range, which is called the laramide orogeny, and it's a kind of a long, complex process. And it's not as much two plates coming together as it is one North American plate that had pressure from the east and the west that buckled up the mountains that we're familiar with. There are also areas of the Rockies, like the Sangre de Cristo Range, Mount Blanca Massif, the east and west Spanish Peaks that are clearly volcanic, extrusive material. And the geology is incredibly complicated, depending on how the blocks moved around and stuff. Probably the best example I know of on Earth of two separate plates that came together and crunched together to form my mountains are the Indian plate and the South Asian plate, which form, of course, the Himalayas and the Hindu Kush and stuff. So a little bit different process here in Colorado. But think of it as one plate that got pressured and then folded up and broken, and that's what created the Rockies.
I know you had your hand up earlier. Do you still have a question, Judy?
I was wondering if the Denver Museum is actually displaying the jaw. Do you know what they're doing with it?
I have not been up there since it arrived, other than when we dropped it off, and I think that's the last. I've been there since, but they did not have it displayed last time I was there, and I'm pretty sure, this is just my guess, they probably won't, because most people who go in there want to see the giant plesiosaurs that are hanging from the ceiling. They don't want to see a little jaw that there's only one species, genus and species left on Earth now. So I think it's probably relatively unimpressive, other than if you're somebody who studies in this particular time frame.
I was thinking of the last scene in the movie, Raiders of the Lost Ark, where the Ark gets boxed up and it's in this unbelievably gigantic warehouse. That's probably where that jaw is. Same place.
We would like to think it's front and center, but until you go and prove to yourself it's not, we can always imagine that it's at least that way.
Kind of in response to Judy, if you don't mind, I worked at a research museum many years ago, and often more of the material in the museum is out there where, or in there, I should say, where it can be used for reference, for research, that kind of deal with what's on display. It's still important, very important, but there's a lot behind the scenes of those museums, at least from where I worked in that kind of deal.
That's absolutely true, because you need access, and that's why it's important to get these artifacts and fossils into museums so other researchers can study them. And that's one of the big problems right now, is a lot of people want to buy their own T-Rex. But that doesn't, if that happens, they don't have to guarantee that other scientists get to come in and use it. And that's why we do put them in museums.
Oh, is this why the repository here would be so important?
Kimberly said
She has an agenda.
why having a repository here at Otero might be of importance, and the answer is, yeah. We think it would be helpful. That, if you consider, there are so many incredible resources in southern Colorado that a lot of people don't know about, and if we have repository status here, they wouldn't have to go to Denver or Santa Fe or Albuquerque or someplace like that.
I would say wouldn't have to go. I would say they wouldn't get to come here and see what we have. So I think it would be a great way to bring in more people, more experts, and kind of show off what we do have in this area. We could get the small repository at least started, and maybe we can expand from there. And it is something we're working on for anybody who doesn't know.
So why can't you get the jaw back?
Well, we could, if we had repository status, and if we were open for other researchers to come in. Dr. Gray's question was, why couldn't we get the jaw back? And the answer is we could. So that transfer of material like that happens between museums frequently if there's a good reason to do it. Yeah.
Did you have a question?
I was going to ask similar to what I said. What's it actually take to get a facility in our area that we can have some of the artifacts that are found in this area to be developed and heal in some way here?
So yeah, the question was what happens or what needs to happen in order for there to be a repository officially here. And Kimberly, here's the microphone.
She's done the hard legwork on this, so that's...
So the majority of what we need is just to get certified. Sorry, I need to be in front of the camera, which I was planning on today. Can you Photoshop an avatar over?
We're going to post.
Make sure this is just a podcast. So we basically just need to go through the paperwork process. We need to get certified that we have museum status, and a lot of what that takes is what kind of environment the artifacts are stored in. So we need a climate-controlled room, first off. Make sure it's a safe space, make sure it's a secure space that not everyone has access to, so people can't willy-nilly go in there and lose artifacts. And so we're going through that certification process right now. We're working through our workbook to make sure that we're meeting all of those those standards. And then it has to go under a review from the National Museum Board, and then it has to go through a review with the State Historic Preservation Office, the SHPO. And then once we get that stamp of approval, we're state certified. And that means that, so Denver doesn't want everything. They already have too much stuff. But they are basically the closest state repository, so that's the central place where everything goes. But once we have that certification and approval, then we can petition to have any local items from this region returned back to us, and they're like, yes, please empty our shelves, take them. They'll probably, if there's anything really exciting like a T-Rex, they'll probably be like, oh, well, this is ours now. But I don't think they would fight with us for the Sphenodont and things like that, locally. So that's the current process.
Oh, the process is that long.
You know, time is such a relative thing. It depends on your time. Yeah.
Are you talking on the geologic time scale?
Typically, it takes a few months, but there's been some changeover in the state. So the state SHPO, a couple of people have retired and they haven't filled those positions yet. And so when I contacted them to say, hey, what's the next step in our paperwork process? They're like, well, why don't you wait till we fill this position and reach out to us in a couple of months. So it's it could happen in a month or two. It could happen in 6 months. It depends on when those positions are filled. So, it's happening. It's just not happening as fast as we would like.
I couldn't help but think of the movie Interstellar. Have you seen it? Depends on how close to Gargantua you are, how time ticks by. It's a great movie. If you haven't seen it, please pick it up and watch it. Anything else? Thank you guys so much. Appreciate it.